So, hello guys, with respect to the previous lecture series, I am going to carry about the torsion sections. In our earlier session, we just seen about the what do you mean by torsion and how the conditions has been assumed for analyzing the torsion in the shaft which has been given any kind of loadings. And along with this we understand about the assumptions. So if you are going to analyze about the torsion in particular section, how can we make some assumptions to solve this torsion problems? So totally it has around 7 kind of assumptions has been given for analyzing the torsion. So in this session we just going to continue with this previous one. Okay, so earlier we just seen the assumptions, and here whenever we going to analyzing the category, analyzing the torsion means we need to take there is a two different kind of condition. One is called the torsional equation T by J is equal to G theta divided by L, which is also written as an tau divided by R. Okay, so wherever the T represents, it is the torque or the twisting moment, and J is nothing but it is the polar moment of inertia. Okay, so polar moment of inertia means whenever the radius of gyration which has been acted towards the center of gravity of the rotation, and because of that the moment of inertia will takes place for the each different kind of load with respect to the mass. Okay, so according to this condition we need to find out what is moment of inertia, that is what you call the J. And along with that radius, it is a major category of the shaft. That radius can be determined based upon the half of given shaft diameter, and we need to say what is the solid shaft or what is hollow shaft. According to the given, we are solving those topic problems. So here T represents it is the twisting moment, or otherwise it is the torque, and J represents it is the angular polar moment of inertia, or wherever the rotational load has been acted, in that case we are having that is what do you call that moment of inertia, that is polar moment of inertia, where polar represents it is the direction of the rotation, either it may be in x-axis or y-axis or z-axis. Okay, so accordingly we need to analyze the motion. Okay, and following that G theta by L, that is G represents it is the shear stress, or otherwise G is also called it as a shear modulus or modulus of rigidity. Wherever the theta we used to call the theta is an twisting angle. Okay, and L represents it is the length of given object or the shaft which has been subjected to the motion. Okay, so that is what you call that L, and tau divided by R is nothing but tau represents it is the shear stress involved, since there if we giving the motion to the shaft, because of the motion of the shaft there is some moment which has been produced, that moment which is acted to the actual applying load. Okay, so that is what you call the torque, right? So based upon that, the shear stress values has been varied with respect to the equal part difference between the materials and the subjected to the loadings. Okay, so that is what here represent tau divided by R. Okay, and T is equal to tau by R. In terms we also can be represent as an torque is equal to radius into shear polar moment of inertia divided by actual radius. Okay, and theta represents it is the angle of the twist, and tau represents it is the shear stress. Thank you.